Hi there. My name is Hong Hua, a solution architect at F5. It is my pleasure to present to you today architectural design considerations for security in IoT solutions. So let's begin.
I'm going to give a perspective on what IoT security looks like, the need to mitigate cybersecurity threats using best practices, and as well as proven security architectures. Security should be a priority in the design of every IoT solution architecture. To do so, we adopt a multi-layered approach in the solution design. Why? Simply because we must adopt a zero trust architecture when it comes to a IoT solution design. You never know at which particular aspect of that solution that a threat factor could emerge. So it is best to treat every single module of your IoT solution as a potential threat to another module. So let's see how we could actually understand some of these threats in order to mitigate them. Now, there have been some significant and also damaging IoT cyber attacks, including the Mirai Botnet attack and the Stuxnet attack on both a DNS provider as well as a uranium enrichment plant in Iran. So there are multiple types of attacks that are also in the world today, including man-in-the-middle attacks, which involves impersonation of a authentic user in order to lead to system compromise, stealing of data and identity, usually IoT data and user identity from the system, resulting in economic losses. Ransomware and malware attacks render operating systems unavailable, and one of the ways to recover from the damages incurred from such an attack would be reuse some of these backups of the operating environment that have been compromised. Denial of service attacks as well are pretty significant in terms of the damage that it could cause to an IoT system. So firewalls and API security plays a huge role in mitigating the various kinds of distributed denial of service attacks. IP spoofing basically would be a means of pretending to be someone you're not. So a threat actor could potentially be trying to compromise an IT solution by manipulating IP packets in order to disguise some of the threat payloads as a legitimate IP traffic. So how do we mitigate these attacks? Adopt a security by design architectural approach. Simply put, you need to start identifying the critical areas in your IoT solution, the connection points and the routes that have to be broken up, isolated, the moment a cyber attack occurs, the moment there has been intrusion into the IoT solution. We call this a kill chain that is built on top of a modular architecture. So identify those modules before you proceed to the next step of your project, which would be coding and implementation. So part and parcel of a zero trust architecture would involve understanding your payload. Here we recommend the encryption of data using a very secure mechanism called TLS. And where we add an M in front, which stands for mutual, we pretty much have the basic building block of a zero trust architecture. When you have a need to perform mutual TLS connectivity at every point of your IoT solution, you're pretty much saying to incoming traffic or users that send these traffic at that you have to authenticate and prove that you're legitimate at any point of time. This is highly recommended, simply put, because you do not know if any of those threat factors that we talked about could emerge in the form that you could least expect and compromise a particular module. Cloud services security and connection security allows you to have the peace of mind that your connections and your code is safe. When we talk about code, we believe containerization of those application assets is key, and we highly recommend the use of a scalable, secure container platform like Kubernetes to run containerized applications. Introduce a edge gateway. That is the next step of the design phase. And where is this edge gateway going to reside? We're going to spend a couple of slides later to explain the importance of having that edge gateway, its positioning. And what it does is it manages and monitors data transfers in order to allow the data to be visualized, at the same time abstracted away from the various modules, and it can be positioned within a DMZ, a demilitarized zone, and at the same time allow only connections that are authenticated using mechanisms like MFA or 2FA before allowing traffic from those particular client endpoints to transmit data to various parts of the IoT solution. Now, API security is important because IoT solutions typically would facilitate the use of APIs, and therefore a scalable, secure API management platform is needed. Like we mentioned earlier on regarding ransomware and malware attacks, operating environment security is paramount. The use of SE Linux enforces policies that will prevent program processes, the likes of malware, from ever running within a Linux environment. And Linux is a very popular operating system used in IoT solutions. Regarding device security, we're going to talk about in a few slides the use of edge gateway to prevent unauthorized devices from connecting, non-compliant devices from connecting to the IoT solution. So we will not spend too much time on the rest. These are fundamentals to any IT solution, and they are firewall security, password security, vulnerability scanning, logging auditing, and user identity and authentication, all of which must be implemented as part of a IoT solution. Not to mention regular patching and using proven implementation frameworks that are supported by quite a lot of engineering teams. Example would be community supported frameworks like Kapua and CUDA. Have a DevSecOps methodology in place in your organization in order to examine any new patches and software releases that may potentially contain critical vulnerabilities that may or may not fall into the category of OWASP top 10. So having a DevSecOps methodology can safeguard against vulnerabilities going into production. So all in all, when we put in place all these best practices, this is what your architecture will look like. You have now the ability to send traffic to various aspects of your IoT solution, which falls into zones like bastion zone, trusted zone, and also the external ones, the internet or intranet. And based on the authenticated traffic, and the IoT solution will be able to manage all this data. Now, when we talk about the various layers within a multi-layer design, we advocate the use of the IoT edge gateway, which plays also as the role of a device manager, firewall, which safeguards against intrusion by bad actors. So one of the key aspects is transport. Use SSL offload as part of your implementation. The edge gateway must be able to perform that role, and SSL should be everywhere. Implement MTLS if it's possible in order to achieve a zero trust architecture. revocation of clients that are considered expired, uncompliant, and also compromised, so that they do not affect the use of the IoT solution. Inspection. What are the various topics that should be exposed? Right? Should it be seen by other clients, or should it only be seen by certain users that have access to some observability tooling or dashboards? Those are considerations that have to go into the design. Traffic steering, for instance, is also very important. Nowadays, the backends of IoT solution could potentially be hosted on the cloud, and they will have many, come in many forms, and they have many different kinds of considerations. So which particular data center are you routing to? Which particular public cloud instance are you routing to? So that is the prerogative of the edge gateway. You must have those policies and rules in place and be able to fine-tune those policies on the get-go. Here's a best practice. Do not just rely on passwords for basic authentication support for incoming traffic or client connectivity. Use it together with certificate-based authentication. That's another layer of authentication that's proven to be very reliable. Security zones, zone out all those various apps so that you will know at which particular juncture a zone might be compromised and therefore needs to be isolated. Again, part of the multi-layer approach. And of course, support for multiple IoT languages. Protocols come in all shapes and sizes. So what are those protocols are you using? Does the firmware of those devices, at the same time, the software in the backend and the middleware, are they able to support these protocols? And are these protocols secure? Could you add a layer of security on top, like SSL? Now, we leave you with a couple of use cases and reading materials. And one of the key use cases that are very popular for IoT solutions involve intelligent vehicle management. So here you can see the edge gateway playing a central role of traffic steering, at the same time device management and authentication of incoming traffic. Smart power metering is also important for quite a lot of national projects. Basically, IoT plays a huge role now in achieving some of those SLAs that are needed in terms of delivering in best-in-class metering. So again, the edge gateway plays a very important role here in application delivery, traffic management, and security, because it manages the interactions and connectivity between all the smart meters with the backend data center where the metering software runs. And I leave you with these reading material, and also thank you again for today's time.